Imagine trying to manage a massive library where every book has to be physically moved by hand every time someone wants to read it, and you have to individually tell each librarian exactly where to put it back. That is a bit like how traditional computer networks operate, with each device making its own decisions. The software-defined networking, or SDN, control plane fundamentally changes this by separating network control from data forwarding. It acts as the intelligent brain of the network, providing a centralized and programmable point for managing all network traffic and devices. This organization allows for a holistic view of the entire network, rather than fragmented device-specific perspectives. At its core, the SDN control plane is typically implemented as a logically centralized software application. This means while the software might run on multiple physical servers for redundancy and scalability, it presents a single, unified view and control point to the network administrator or automation systems. This central controller uses what is known as a southbound application programming interface to communicate with and program the underlying data plane devices, such as switches and routers. The most well-known of these is the OpenFlow protocol, which defines a standard way for the controller to install forwarding rules onto the network devices, dictating exactly how packets should be handled. Simultaneously, the control plane exposes a northbound application programming interface. This allows various network applications to request network services, apply broad policies, and gain deep visibility into the current network state. Think of these network applications as specialized tools like traffic optimizers, security policy enforcers, or load balancers, all interacting with the network through this unified control point to achieve specific operational goals. This architectural separation between control and forwarding makes the network much more agile and adaptable, moving intelligence away from individual boxes. So, what does this mean in practice for managing networks? Well, with an SDN control plane, network administrators can program the network behavior from a single, centralized location. Instead of logging into dozens or hundreds of individual network devices to configure them one by one, they can define network policies and traffic flows through software. This enables automated deployment of network services, dynamic adjustment to changing traffic patterns, and much faster troubleshooting. It essentially transforms network management from a manual, device-centric task into an automated, network-wide one. A key concept here is the network operating system, which often sits within or atop the SDN control plane. This operating system provides an abstraction layer, making the complex underlying hardware appear as a single, programmable entity. It simplifies network orchestration significantly. Another interesting aspect is the ability for multiple independent SDN applications to coexist, each requesting specific network behaviors from the control plane without interfering with each other's operations. This concept of programmatic control allows for innovative services and much greater flexibility than previously possible. Ultimately, the SDN control plane's organized architecture revolutionizes how networks are designed and operated. By centralizing intelligence and providing robust application programming interfaces, it unlocks unprecedented levels of network automation, agility, and efficiency. This enables organizations to build highly responsive and adaptable network infrastructures that can quickly evolve to meet new demands and challenges, ultimately delivering better performance and service quality.
If you love understanding how the web works, like, subscribe, and stay connected with us.